I will be discussing about pressure flow studies. I will be covering my topic under these headings. The basic urodynamic physiology like this. During the filling phase, the bladder detrusor muscle is relaxed and the external and internal sphincter are contracted. And this effect is augmented as the bladder continues to fill by secondary urethra to bladder and bladder to urethra reflex. In pontine maturation center, there is a switch during voiding phase, and this switch leads to relaxation of sphincter and contraction of detrusor muscle. Similarly, this secondary urethra to bladder and bladder to urethra reflexes are also switched, which leads to a good, efficient lower urinary tract function during voiding. Now, in pressure flow study, we are actually looking for two predominant parameters. One is we want to assess the detrusor strength. That is exemplified by detrusor contractility index. Now, this works irrespective of whether there is an obstruction or not. Now, the second parameter we were looking at is bladder outlet obstruction. We want to know whether it's present or not. If it is there, how severe is it? And thirdly, we want to decipher the location of obstruction. So we can see this urodynamic graph, and we will concentrate only on the voiding phase in this. In the voiding phase, we are looking at the point of least resistance, that is P det at Qmax and the Qmax point, because we cannot look for the whole average of the whole voiding parameters, because this is going to be very complicated graph. We are looking at detrusor contractility index. In men, it is defined as P det Qmax plus 5 times Qmax. A normal value is about 100. Anything less than that is considered to be weak, particularly if it is less than 50. And a more than 150 value exemplifies a strong detrusor. In women, the situation is far from clear, although some papers have mentioned in older women the period Qmax plus Qmax as a definition of detrusor contractility index. However, reference values are not known. The situation is more clear in assessing bladder outlet obstruction. There is a bladder outlet obstruction index for men. We all know for a long time, which is P det Qmax minus 2 times Qmax. And we all know very well a value of less than 20 refers to unobstructed relation, 20 to 40 equivocal, and more than 40 definitively obstructed. In women, also P det Qmax minus 2.2 times Qmax defines bladder outlet obstruction. The value of less than 5 is unobstructed, 5 to 18 equivocal, and more than 18 is obstructed. So we can see both are similar formulae, but the cutoffs are different. Now, if we were to analyze this graph on this point in a graph, so we would go for either a ICS nomogram, which represents both situations, that is detrusor contractility as well as the presence of obstruction in one single graph. We'll see how. This period Qmax point is here as a red dot. We can see these vertical lines from left to right. So on the left side, unobstructed, between these red lines is equivocal, and right to the red line is obstructed. So this is borderline obstructed. Similarly, we're looking at blue lines from below upwards. Below is weak, between lines is normal, and more than above the blue line is strong detrusor. So this patient has normal detrusor and obstructed outflow. Same situation is also represented on Schaeffer's nomogram, which is based on linear PURR. We'll not go into much details of this definition of linear PURR, but it basically tells you the same thing in more number of categories, from very weak, normal to a strong, and obstruction from 0 to category 6. Now, let us take one by one. In obstruction, we're looking for whether it is bladder, neck, or prostatic obstruction, or it is sphincter or pelvic floor dysfunction. So in bladder, neck, or prostatic obstruction, or in females uterus stricture, when sometimes we do urodynamics, what is happening is there is a physical obstruction which can be dynamic or static. However, These secondary reflexes, which affect the function of sphincter and bladder, are intact. So what is happening in these cases? You have high pressure, low flow, but the reflex is normal, so the detrusor contraction is a very smooth bell-shaped pattern. And in these Schaefer and ICS nomograms, you can see that you have a normal detrusor function and obstructed outflow. In this situation also, flow is very good. The pressures are quite low. This is a patient of overactive bladder. And these blinking red lines show the location of P at Qmax point, which is obviously unobstructed and in good detrusor function. Now comes the low pressure, low flow, detrusor underactivity. Now, before I go further, I would like to mention in presence of detrusor underactivity, it is at times very difficult to analyze presence of bladder outlet obstruction on pressure flow study. Like you can see here, there is a very low pressure and the flows are quite poor. You can see the detrusor is obviously very weak and it shows unobstructed outflow also. But I would like to say it is not necessary. Now coming to atonic bladder. This is the example of orthotopic new bladder. We can see obviously there is no active detrusor contraction. These are all phasic contractions of the ileum, and the patient is voided with straining, obviously with pelvic floor relaxation. Now, calling any void as atonic, one should be very careful. Know that in this kind of situation, the patient's detrusor will not be contracting like in orthotopic new bladder, meningomyelocele, extreme diabetic uropathy, like that. However, otherwise, if because of some situation the patient is not able to void, and you are assuming that this patient should have a normal reflex, that case, calling atonic bladder is kind of incorrect. We have to look into the actual explanation why this bladder could have been atonic. So after trying to answer the first two questions, that we want to know where is the obstruction. So we are actually looking for bladder neck or prostatic obstruction and poorly relaxing external sphincter or pelvic floor dysfunction. So there are some more studies in our armamentarium like urethral pressure profile, doing a video urodynamics or doing a MCUG separately, doing an EMG, and trying to read between the lines of PFS. I will be taking one by one. Like in urethral pressure profile principle, how the physics works. During voiding, if the whole outlet is nicely open, then the P vesicle is transferred equitably into the urethral. So that means the P vesicle is equal to P urethra. So that means the P closure should be zero, as in this example you can see here. However, in obstructed case, what will happen? At the point of obstruction, the P vesicle will not be transmitted properly in the urethra, and the P urethra will be lower than P vesicle. So that means the graph of P closure will go suddenly in the minus at the location of obstruction. Now, this is how one can determine the location of obstruction. MCU UDS, how it helps is obviously the localization of suction, bladder, neck, external sphincter in these examples, male and female. And this lady has a significant cystocele, which is seen on MCU, reflux, diverticula, all these things will be seen on MCU. That's the advantage. Now, EMG, during voiding, the activity should reduce, and that represents presents the relaxation of external sphincter is proper, and the secondary reflexes are working all right. However, if during voiding the EMG activity has increased, so that will exemplify some problem in the external sphincter of pelvic floor. I would like to emphasize here, EMG can tell whether there is a problem at external sphincter or not, but it cannot tell is there an additional problem in the prostate and bladder neck or not. These secondary reflexes, if these are normal, the detrusor pattern is generally bell-shaped. However, in cases of external sphincter dysfunction or pelvic floor dysfunction, these reflexes are impaired, and these impaired reflex hamper the detrusor contraction, and thereby the detrusor contraction looks like a plateau or a plateau with irregular pattern, unlike a nice bell-shaped pattern. This is our original research, and we have found about 90% predictability of presence of this pattern in proving that this is a external sphincter or pelvic floor dysfunction. So taking this example, in bladder neck obstruction, we can see high pressure, low flow. We can see on UPP, there is a dip right from the bladder neck in the utheal pressure. Then there is an EMG relaxation. And the graphs also show the period Qmax in obstructed range. In a sphincter, you will see a plateau detusor pattern. The pressures are relatively low. Urethral pressure profile dip is in the region of mid-urethra. So to conclude, dual channel pressure flow studies provide important information regarding bladder function and the presence or grade of obstruction. Detusor pattern also we can interpret whether the problem is at the sphincter or not. Now, in some situations, further studies like MCUG or video urodynamics, urethral pressure profile, and EMG may provide additional information on location of obstruction. So thank you very much. Use urodynamics judiciously and intelligently. And before leaving, I would like to request everyone to take a pledge not to use antibiotics by habit and always think twice about the indication. Thank you very much.